Good morning, everyone. Okay, we'll continue our book reading this morning, The Toyota Way to Service Excellence by Jeffrey K. Lycan and Karen Ross. Yesterday, we looked at the concept of sales in service organization. Today, we'll be looking at Ziegman's mail order and one piece flow. Ziegman's mail order and one piece flow. One type of service organization that learned this lesson in Ziegman's mail order launched in 1996, ZMO receives and ships high-quality artisan foods throughout the United States. The core crew includes about 70 employees, but the workforce can grow to more than 400 during the holiday season, Thanksgiving through Christmas, when the company sells 50% of its yearly volume. Fortunately for ZMO, it grew rapidly, but unfortunately, that meant even more chaos each year, as it needed to store more stores and quickly outgrow whatever facility it was in. Every few years, ZMO went through the painful process of moving to a larger warehouse where it could store more stuff. It was costly, but the company was profitable, so it thought the situation was one it has to live with. In 2004, ZMO decided to try its hand at lean and sought help from one of my doctoral students, Eduardo Landa, who was studying lean in high variety, low volume organizations. Edward immediately noticed stagnation every place he looked. Boxes of stuff were piled high, raw materials were scattered everywhere, including in aisles, and there was no discernible flow. ZMO was doing a lot of batching. For example, he prepared all the orders for cheese on trays at the beginning of the day, and then the trays were piled meters high and stocked somewhere or someplace. Team members seemed to spend as much time walking around finding stuff as preparing customers' order, as Eduardo explained. At the beginning of the day, each support process would work to prepare the products indicated in the end of the day's sheet. The line would only start running when all support processes were done with their prep work and all products were available for picking. At this time, the order starter would place pick sheets in tubes and put them on the conveyor as fast as the line would take them. If she saw that a station had little work, she would sort through the orders and release some that increased the load for that person. Alternatively, she would also move people from low to high load areas to try to speed up the lines. Unless done very carefully, the combination of these two practices created waves of orders that exacerbated the imbalance and further amplified precisely the problem the order starter was trying to solve. As a first step, Eduardo recommended creating some semblance of flow using a conveyor system. At the start of the line, employees select the item customers ordered and put them in bins, flowing on conveyors. They go through a variety of checking and boxing steps and then packaged orders. And then the packaged orders flow directly to the truck they are loading for shipping. To their credit, the senior leaders worked with Eduardo and took the risk of developing and using the flow line just in time for the busy Christmas season. It worked a bit crudely, but was a marked improvement. Next, Eduardo said the company needed to stop batching and instead cut the bread and cheese and prepare the dairy product. One customer ordered at a time. It was rough, but there was an immediate positive impact. Order was being introduced into what once had been chaos. Customers' orders were being assembled faster in sequence and the error rate was reduced. Aisles were cleared and space was freed up. ZMO has continued on this path for almost a decade, and now flow is clean and smooth. A daily task, the minutes in a day divided by expected customer demand for given date, is calculated, showing the number of seconds available to pick an order and put it into a container. This spaces the operation. What is interesting is that the number and size of orders varies every day and throughout the day. Under such condition, it is easy to throw up your hands and say tax can not be calculated. Instead, ZMO has developed 5 standard tax levels measured in seconds, all of which are multiples of 8, that is 8 seconds, 16 seconds, 32 seconds, etc. Standard staffing has been established for each task. Each day, based on actual order and forecasted orders, the task is set. At the beginning of the line, in the peak zone, the computer system schedules customer order based on the task and prints out the picking list for each customer at the rate of task. The task is not precise as orders are being added as people call in during the day. If there are fewer orders than expected, employees leave early, and if there are more orders, employees will work late. Throughout the day, floor leaders have some latitude to change the task if they see a need. Notice on the task board that there are places to write in the planned task, the forecasted task, and the actual task, along with a column for why. Forecasted task is what is forecasted based on general trends. Planned task is what is set for the day based on what is entered into the computer system about actual orders and backlogs by that morning. Actual task is the adjustments made by managers as the day proceeds. Making this difference visible is an important part of the continuous learning system. Differences between what is expected and what actually occurs have many possible causes, and as those deviation from expectation are addressed, the system becomes increasingly stable. One of the most dramatic benefits for ZMO is that it has been able to stay in the same facility for almost a decade. It has also seen large increase in customer satisfaction and profitability. In the short term, when the changes were first introduced, labor cost as a percentage of sales was reduced by 38%. Boxes per labor hour increased by 47%. Defective shippings were reduced by 18%, and the cost of mistake was reduced by 29%. Needless to say, the owners are deeply committed to lean over a decade later. Okay, so this is your stuff for our reading this morning. Still looking at ways and in different industries where you can actually achieve a one-piece flow when you apply the lean principle. So like I said, it's not just in the manufacturing industry, it can be done anywhere. Like the example we looked at yesterday, you use a medical facility as an example and how lean can be used in that organization. And before you apply lean in your organization, first of all, identify the waste, identify the problems, identify those things that could cause hitches or cause time wasting or not bring an effective or produce an effective customer service. Look for those things and try to know how you can apply lean in all those places. This is your stop for now reading today. Thank you.